Hello everyone, my name is Arya Devdar and this is part 6 of NCERT Class 10 Science, Chapter 2, Acids, Bases and Salts. Okay, so in the last chapter we started with salts, right? So we saw the family and pH of salts and then we started the types of salts. So we saw common salt, sodium hydroxide as well as bleaching powder, CaOCl2, correct? So in this part, we are going to continue different types of salts. Okay, so in this part, we are going to see baking soda. Okay, we are going to see what is baking soda. Okay, its uses, its preparation, everything. Okay, then we are going to see washing soda. Okay, washing soda. And lastly, not lastly, I'm sorry. Before the last salt, we are also going to see an important concept which is known as water of crystallization. Okay, I'm sorry, water of crystallization. And the last salt, which we are going to see, is gypsum or POP. So most of you know what POP is. It is plaster of Paris, right? So we are going to see this in this part, these topics. Okay. So let's start with the first one, which is baking soda, right? So what exactly is baking soda? Okay. So you might have heard your mother using baking soda in making cakes or cupcakes or bread, fermented items, right? So why is that used? So there must be some chemical reaction which takes place, right? So let us see that. Firstly, baking soda, the chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. Okay, so it is sodium hydrogen carbonate or otherwise sodium bicarbonate, whichever one you like. It is NaHCO3. NaHCO3. So this is a chemical compound which is also known as which is commonly known as baking soda, right? Okay, so this preparation method, let us see the reaction for preparation, right? So preparation. So the reaction is as follows. This is also prepared from common salt, right? It is also prepared from NaCl. So the reaction is NaCl plus H2O plus CO2 plus NH3. Okay, this gives NH4Cl plus NaHCO3. This is not gonna fit. Yeah, here we go. Yeah, NaHCO3. NaCl is sodium chloride, sodium chloride. NH4Cl is a salt we have seen in the family of salts, ammonium chloride, right? It is a byproduct which is formed, sorry, ammonium chloride, and this is sodium hydrogen carbonate, sodium bicarbonate, which is our main product, right? Okay, so this sodium hydrogen carbonate, it is a basic salt. It is a mild, non-corrosive basic salt. Okay, and write that down. Mild, non-corrosive, obviously because we eat it, right? So it is a mild, non-corrosive basic salt. It is basic in nature. Okay, okay. So you might have also heard that when you get stung by a bee, right? Then if you put some apply some baking soda on it, then it relieves the pain. Why is that? Because it is a basic. It is basic in nature, right? We know that ant stings leave methanoic acid. So when we rub this basic salt on it, it relieves the pain. Okay, so that also proves it is a basic salt. Okay. So now when it is heated, okay, so basically what I mean to say is when your mother or maybe even you put it in the cake, right? Put it in the ingredients of the cake and mix it and you put it in the oven. So basically it is heated, right? So the following reaction takes place when it is heated. See, NaHCO3 with heat, okay, it gives Na2CO3 plus CO2 plus H2O. Okay, now the CO2 is the most important part. Why? Because this CO2 The carbon dioxide produced, it causes the bread and cake to rise and become spongy. Okay, it becomes soft and spongy. Okay, so that is why NaHCO3 is used in cakes. Okay, or maybe even samosas and all that, right? So this is the basic reaction which takes place. Na2CO3 is sodium carbonate. NaHCO3 is sodium bicarbonate. Don't confuse both of them. Sodium carbonate, sodium hydrogen carbonate. Okay, there's a difference. Okay. So now let us see the uses. What are the uses, right, of baking soda? See, uses. The first use is it is used for making baking powder. Making baking powder. So what exactly is baking powder? Baking powder is basically NaHCO3, which is baking soda, plus a mild edible acid. It can be tartaric acid, right? Usually tartaric acid is used. Okay. So it is a mixture of baking soda and a mild edible acid. So when this is also added in cakes to make them rise and fluffy, right? So what reaction takes place when it is heated, when baking powder is heated? So see, NaHCO3 plus. Now here H plus. I'll only write H plus because that is what we need for this reaction. It is actually an acid, a mild acid. Okay, so tartaric acid has a very big formula. So I'm not writing the whole thing here. Instead, we just write H plus. It represents any mild edible acid. Okay, H plus. NaHCO3 is baking soda. So this gives CO2 plus H2O plus the sodium salt of the acid. Okay, sodium salt of acid. So इतना जो है from this is prepared from Na and the remaining part of the acid, a salt is prepared. Okay, so this is the basic mechanism of the reaction. I'm sorry. Okay, so the carbon dioxide produced here, it is in the gaseous form, and this during the reaction it causes the bread or cake to rise, making it soft and spongy and fluffy. Okay, so this is the first use of baking soda to make baking powder. Okay, second, second, it is also used as an ingredient in antacids. Ingredient in antacids. Okay, so why? As I said, it is a mild basic salt, non-corrosive, right? And antacids are basically to neutralize excess acid produced in our stomach. So hence, it is used in antacids. Being alkaline, it neutralizes the excess acid and it provides relief. Correct? Okay. And the third use is it is used in soda acid fire extinguishers. Soda acid fire extinguishers. Okay. So these are the three important uses of baking soda. They can be asked in the examination. So make sure you remember it. Okay. Now we'll move on to the next salt, which is washing soda or washing powder. Okay, it should be actually soda. I'm sorry. Soda is the correct word. Washing soda. Yeah, okay. So what basically is the chemical formula of washing soda? This is also prepared from indirectly it is prepared from sodium chloride itself because see in this above reaction, this one. You see this Na2CO3 which has been prepared. This Na2CO3 is used to prepare your washing soda. Okay. So this has indirectly been prepared by common salt itself, right? So hence it is washing soda is indirectly prepared by common salt. Okay. So yeah, washing soda, its chemical formula, yeah, its chemical formula is Na2CO, I'm sorry, Na2CO3 dot 10H2O. 10H2O. So this is its chemical formula. Okay. So as we have seen that sodium carbonate can be formed by heating baking soda, correct? And the recrystallization of sodium carbonate, it gives washing soda. Okay. So I'll write down the reaction here. So Na2CO3, sodium carbonate, plus 10H2O, sorry, 10H2O gives Na2CO3 dot 10H2O. Okay. So this is also a basic salt. Remember, this is also a basic salt. Now you might be wondering here that the dot 10H2O which is present, does that mean that the salt is wet in general or it does not exist in a solid form? Is that what it means? So no, that is not exactly what it means. But we'll discuss that in water of crystallization. Okay. For now, let us see the uses of washing soda. Okay. So there are four important uses of washing soda. Let us see one by one. Correct? Uses. The first use is it is used in glass, soap, and paper industries. Washing soda. Na2CO3 dot 10H2O. Okay. Paper industries, paper factories, right? The second use, it is used in the manufacture of sodium compounds like borax. Okay. It is used in the manufacture of sodium compounds like borax powder, right? We have used borax powder. We use it in our daily day-to-day activities, correct? The third use, it is used as a cleaning agent for domestic purposes. Okay, it is a basic salt, right? So it is used as a cleaning agent for domestic purposes only, not for industrial purposes. For industrial purposes, we need some stronger bases, correct? This is a mild base, not very strong. Okay. And the last one, which is the most important, it is used for removing permanent hardness of water. Removing permanent hardness of water. So this is asked a lot in the examination. This property especially. Okay, they ask which compound is used to soften hard water. Okay, this is their question, and people get confused. So you have to remember that it is washing soda. Okay, so permanent hardness of water, hard water and soft water, right? Hard water is basically water which contains some specific salts like magnesium salts. Okay, so that is known as hard water. So hard water is basically borewell water. Okay, and soft water is your normal tap water. So this washing soda, it is used to remove the permanent hardness of water. Okay, understood? Okay, now we'll move to water of crystallization. Okay, this is again very, very important. Understand. Okay, so water of crystallization is basically the fixed number of water molecules present in one formula unit of a salt. For example, see washing soda itself. See this. This is one unit, right? One mole, one unit, whatever you want to call it. It's one unit, correct? So this one unit, right? It contains 10 molecules of water, correct? So that is its water of crystallization. So the water of crystallization of washing soda is 10, 10 units, 10 units of water. So what is the basic definition? I'll write it down here. Fixed number. It is the fixed number of water molecules present in one formula unit. In one formula unit. That means one mole, or basically one formula unit is when you write in a chemical reaction, you write the numbers, right? 1, 2. So in that one is one formula unit. One unit of that. Okay, so one formula unit of a salt. That is its water of crystallization. Okay, let me give you some examples here. So one we just saw, one example. The first example is Na2CO3 dot 10H2O. So we just saw this, right? 10. So this is washing soda, correct? So this basically means that the salt itself is not wet, but inside the salt, water is present. Inside the molecules, there are molecules of water present in the actual structure of the compound. That is basically the water of crystallization. Okay. So the second example you'll understand more with the second. The second example is of copper sulfate. So CuSO4. You all know CuSO4. We just write it CuSO4. But its actual formula is CuSO4 dot 5H2O. So five water units are present in one formula unit of CuSO4. Okay. So what happens, if you heat, for example, if you heat copper sulfate crystals, which are blue in color, right? If you heat these copper sulfate crystals, they will lose their water of crystallization, right? It will get evaporated, and the blue color it will change to white. Okay, so that is basically anhydrous. Anhydrous CuSO4. It does not contain any water of crystallization. Now, if this white salt is mixed with water again, right? Then it again turns blue, and this is formed. I'm sorry. Right? This is formed. This salt is formed. Understood? Okay. So chemical formula for hydrated copper sulfate is this. Hydrated. Both all of these salts are called hydrated salts. Okay. Another example, one more. It is FeSO4. FeSO4 is green in color, right? Iron sulfate and oh, I'm sorry. I'm sorry. Yeah. Iron sulfate and its water of crystallization is 7H2. Okay. 7H2O. So there are seven units, seven water molecules present in one formula unit of FeSO4. Correct? Okay. So these are three examples. Now the next example we'll see in plaster of Paris. Okay. So plaster of Paris is fun. See, there is a salt called gypsum. Okay. It also contains water of crystallization. Okay. So when this gypsum, it is heated at 373 Kelvin, okay, which is 100 degrees Celsius, right? And it is heated at 373 Kelvin, it loses the water molecules and it becomes plaster of Paris. So what is the chemical formula of plaster of Paris? Again, a very fun formula. Okay, it is CaSO4 calcium sulfate dot half H2O. Okay, very interesting. Half H2O. Its chemical name is calcium sulfate, calcium sulfate hemihydrate. Hemihydrate. Hemi means half. Half hydrated. Like half H2O, right? So hence it is hemihydrate. Calcium sulfate hemihydrate. That is basically POP, plaster of Paris. Okay, this POP when it is mixed in water, right? After mixing in water, doctors use it to plaster your arm, right? To keep it in one place, to keep it rigid. Correct? It is also used in making cement and, plastering of walls and all that, right? So basically that means plaster of Paris, the powder, this compound, when it is mixed with water, it forms a hard mass, right? It forms a hard, really tough, rigid mass. So basically, what does it form? It forms gypsum because gypsum is dehydrated. Uh, Plaster of Paris is basically dehydrated gypsum. Okay, so I'll write down the reaction, then you'll understand. See, the reaction goes as follows: CaSO4, so this salt dot half H2O plus 3/2 H2O, 1.5 H2O. It gives CaSO4 dot 2H2O. This is known as gypsum. Okay, so here the water of crystallization of gypsum is 2, right? Two water molecules in one formula unit, correct? So when this gypsum, it is heated at 373 Kelvin, okay, 373 Kelvin temperature, 100 degrees Celsius, it loses the water molecules, right? And it forms plaster of Paris, okay? So again, when this plaster of Paris it is mixed with water, it gives gypsum. And this gypsum, it is a very hard, rigid substance. Hard, solid mass. Okay. It is a hard, solid mass. Okay. Now, remember one thing which you have learned. Okay. From you might think that this half H2O is kind of weird, right? You know that atoms are indivisible, right? They cannot be divided further. Okay. So then how can a molecule be divided into half? That might be your question, right? So see, this formula, it basically means, right? We can also write this formula here. I'll make it easier for you. We can also write this formula. If you multiply this 2 here as well, here as well. So what we'll get 2 CaSO4. This 2 and this 2 will get cut. So we'll get dot H2O, 1 H2O. So what does this formula basically mean? It means that two CaSO4 molecules share one molecule of water, H2O. So two formula units of CaSO4, they share one molecule of water. So that when it is, a bit simplified, then it is written one CaSO4 unit gets half molecule of water. That does not actually happen. This actually happens. Okay. This is the actual formula or the actual reaction which takes place. Okay. So we'll now write down the uses of this finally, right? The uses of plaster of Paris. You might already know it, but still, it is used for making toys, decoration, decor, right? Materials for decoration and also making surfaces smooth, right? Smooth surfaces, correct? So those are the two uses. Other than that, plaster of Paris or gypsum is also used for plastering, right? Plastering of walls or your hand, right? Plastering of limbs, correct? By doctors. Okay. So these are some of the important uses of plaster of Paris. Okay. So in this way, we have finally completed the chapter acids, bases, and salts. Okay, so we have seen every minute detail of this chapter very, very thoroughly. We have completed it, right? I hope you have understood everything. Okay, so that's it for now. Thank you so much.